1 plus x over 1 minus x in ascending powers of x up to the second, up to x squared, and then show that the square root of 3 over 2 is 61 over 50. It was a different question, but then that one was too easy. So just to make it a little bit spicier, find the square root of 3 over 2. And if you know what square root of 3 over 2 is, you can check that in a calculator. It's going to be roughly the same as 61 over 50. So we need to show this. So let's do that. So first, we need to use binomial expansion to expand 1 plus x over 1 minus x. So first, you just have to start by, you have 1 plus x over 1 minus x, and this is being square rooted. So of course, how we're going to do is we're going to have to rewrite this. This 1 plus x over 1 minus x, we're going to rewrite it as 1 plus x being square rooted over 1 minus x, also being square rooted. And since that is what we have, we can then rewrite that as 1 plus x. Remember, square root means you're raising it to the half power. So we're raising this to the half power over, this is really 1 minus x to the half power. Then we can bring that up into the power to get this to be equal to now. This is now 1 plus x to the half. This is now 1 plus x to the half, and this is being multiplied by 1 minus x to the minus half. Yeah, man. This is now 1 minus x to the minus half. So if you're applying the binomial expansion formula, now this is going to be equal to 1 plus nx. So this part right here is going to be equal to 1 plus nx, and in this case is a half. So it's going to be 1 plus a half times x plus n times n minus 1. So it's going to be a half of x, well, a half, that's n times n minus 1. N minus 1 is minus a half, x squared. It's now x squared over 2 factorial, which is just 2. And then that is being multiplied by, now we're going to expand out this part right here. This part right here, it's going to be 1 plus nx, but in this case, n is minus a half. That is 1 plus nx, which is minus a half, times x, plus n times n minus 1, which is n, times n minus 1, which is now minus 3 over 2. And remember, this is actually minus x. This is actually minus x. This is minus x. So this one is going to be minus x squared over 2 factorial. Now we're going to simplify this. Now to simplify this, what we're going to get is that this works out to be equal to, this side is now 1 plus a half x. You can simply just write that as x over 2 plus, well, it won't be plus. Because of the minus, this will actually be, 1 times minus 1 is minus 1, so that's minus x squared over 2 times 2 times 2, that's 8. So that's 1 plus x over 2 minus x squared over 8. Multiplied by this part will simplify out to be, that looks like 1 plus x over 2 that's x over 2, and then let's simplify this now. Minus 1 times minus 3, that's minus, that's plus, then we have minus x squared, so that will work out to be plus 3x squared, and this 3x squared is going to be divided by 2 times 2 times 2, that's 8. So we get 1 plus x over 2 minus x squared over 8 times 1 plus x over 2 plus 3x squared over 8. To simplify this part now, it's going to work out to be 1 times all of this, 1 times all of this. This is how we expand 1 times all of that. That's what we do first. So it's going to be 1 plus x over 2. I don't want to miss any step, so I think I'm going to write it out. Just to write it out, we know that it's going to be 1 times all of this. So let me go and do it on a new page. So we have right here equal to 1 plus x over 2. This was minus x squared over 8. This was what we have, minus x squared over 8, and it was multiplied by 1 plus x over 2. Then it was plus 3x squared over 8. And quite as we rightfully said that we're going to have to expand this by going 1 times all of this, 1 times all of this, which is 1 plus x over 2 plus, this is now 3x squared over 8, 3x squared over 8. And then we have x over 2 times all of this. So it's going to be plus x over 2 and x over 2 is being multiplied by everything in here again. 1 plus x over 2 plus 3x squared over 8. And then finally, we're going to multiply minus x squared over 8 minus x squared over 8 times everything in this bracket. Times everything in this bracket, which is still just 1 plus x over 2 plus 3x squared over 8. That's what we do. That's what we do. Nice. And then now what we get is this is equal to 1 times all of this, that works out to be 1 plus x over 2 plus 3x squared over 8. And then we have x over 2 times all of this, that is plus x over 2 plus x squared over 4 but look at this now, x over 2 times 3x squared over 8. That's going to give us a cube term, so we can ignore this. Ignore this part, ignore the cube term part, so we can just go minus x squared. All right, we can just go minus x squared over 8, and we'll stop right there. So notice I ignored this. I didn't multiply them. Ignore that because that's an x cube. So we ignore that. We only want to expand up to square. So we ignore that. And over this side, notice what we ignored. We ignored multiplying the x squared times this, and we ignored multiplying x squared over 8 times this. We ignore those because that won't give us any x squared. So we ignore those. So we ignore those now. And so what we finally get is finally, drum rolls, this is going to be 1 plus, let's see now, x over 2 plus x over 2. X over 2 plus x over 2 is just x. And then we need to add 3x squared over 8 plus x squared over 4 minus x squared over 8. 3 and 2 is 5 minus 1 is 4. So that's going to be plus 4x squared over 8. So that is 4x squared over 8. A lot of people will simplify this to just be x squared over 2. So let's just write it as 1 plus x squared over 2. So this is decent. 1 plus x squared over 2. And we can leave it at that. So now that we can leave it at that now, we're good. Nice. So we can rewrite that all of this expansion, we can tell them that that expansion, we found that it's simplified to be 1 plus x over 1 minus x. We found that this is working out to be 1 plus x squared over 2. That's what we get here. Nice and easy. Soft with a capital T. Soft with a capital T. Then now we need to show that root 3 over 2 is 61 over 50. Show that root 3 over 2 is 61 over 50. What you're going to do is, in order to find what the square root of 3 over 2 is going to be, what I would do is, this is just how I look at it. I like to analyze and see what value of x can I put here for it to work out to be 3 over 2. What value can I put for x here that will let this simplify to be 3 over 2? So a lot of people would equate 1 plus x over 1 minus x to 3 over 2. If you equate them, that is fine, and you solve for x, then you can put in that value for x. But I have another way. I like to try values. So in a case like this, what you're going to do is let x equal 1 over 5. And you might say, why 1 over 5? It's just something you observe. The more you practice, the more you'll be able to observe these numbers. So if I let x equal 1 over 5, then what I get is 1 plus 1 over 5 is 6 over 5, because I am seeing 6 over 4 if I put x as 1 over 5. So the more you practice, the more you see it. So look at this. We put x as 1 over 5. Then what we're going to get is the square root of 1 plus 1 over 5 over 1 minus 1 over 5. And what we're going to end up getting is that this is equal to 1 plus 1 over 5. That is now x, because we let x equal 1 over 5. Plus, it's going to be 1 over 5 square over 2. 1 over 5 square over 2. Then look at this now. 1 plus 1 over 5 is 6 over 5. So I get 6 over 5 divided by 1 minus 1 over 5 is 4 over 5. Yeah, man. And we're square rooting all of this. Nice. And that works out to be 1 plus 1 over 5. That's just 1 plus 1 over 5 plus, now 1 over 5 square is 1 over 25 over 2. That's 1 over 50. This is 1 over 50. Nice. So what am I going to do now? Well, what I'm going to do is I note this. Look at this right here. This part works out now to be the square root of 6 over 5 divided by 4 over 5 is 6 over 4. And the square root of 6 over 4 is the square root of 3 over 2. Nice. Square root of 3 over 2. So we're getting that the square root of 3 over 2 is add up all of this. But 1 plus 1 over 5 plus 1 over 50, 1 can be looked at as 50 over 50. That is 50 over 50. And 1 over 5 can be seen as 10 over 50. And then 50 plus 10 is 60 plus 1 is 61. So that works out to be 61 over 50 shown. So the square root of 3 over 2 is 61 over 50, which is 1.22. So you can start binomial expansion is very, very, very accurate. It is very accurate. Now look at what I'm going to show you now. I'm going to show you that if you're to square root 3 over 2, you're going to get 1.22 as a rough estimate. If you're rounding off to 3 decimal place, that's what you'll get. So here's a verification of the solution. If you find the square root of 3 divided by 2, look at this. Square root 3 divided by 2, I get 1.22474. But notice that we also got 1.22 from our expansion. So binomial expansion is very accurate. Nice. So that's that example. Let's look at another one right here. This one says find the expansion of 1 plus x to the half up to x cubed, and hence find the square root of 1.5 correct to 4 decimal places. So find the expansion of 1 plus x to the half up to x cubed, and hence estimate the square root of 1.5. So let's go ahead and do this. We need to find the square root of 1.5. And so to find the square root of 1.5, after we find an expansion of this, that's easy. So we know that 1 plus x, all right, let's not write right here, 1 plus x to the half. Let's go to our whiteboard. So we want 1 plus x to the half. Now 1 plus x to the half, as we know, 1 plus x to the half is equal to 1 plus x to the half, it's going to be equal to 1 plus nx. N is a half, so it's a half x. So it's a half x plus n, where n is a half, times n minus 1. N minus 1 is going to be minus a half times x squared over 2. So that's x squared over 2 plus n, which is a half, times n minus 1, which is minus a half, times, this is now n minus 2, which is minus 3 over 2, x cubed over 3 factorial. 3 factorial is 6. So this is our expansion. So what we get is, this is now 1 plus, that looks like x over 2. This part simplified to be, this is minus x squared over 8. And then this part is working out to be minus and minus make it become plus now. So that is now 3x cubed over 2 times 2 is 4, 4 times 2 is 8, 8 times 6 is 48. If you want to simplify it, you could, you don't have to. That would just be 1 plus x over 2, 1 plus x over 2 minus x squared over 8. And then you have minus 1 over 3 over 48, that works out to be minus 1 over 60. So it's really minus x cubed over 60. Nice. So that's what we have, plus. So let's go ahead and write that down now. That all of this 1 plus x square rooted, remember to the half power means square rooted. So we can write now that 1 plus x being square rooted, we found that it is 1. It is 1 plus what? It is 1 plus x over 2 minus x squared over 8. 1 plus x over 2 minus x squared over 8. And then it was plus x cubed over 16. This is what we get. Easy, soft. Then the next part says, hence find a square root of 1.5 to 4 decimal place. Now, in order to get 1.5, we're going to have to let x equal 0.5. Let x equal 0.5. Because if we get let x equal 0.5, what you're going to get is the square root of 1 plus 0.5, which is of course your 1.5. Let x equal 0.5, so you get the square root of 1 plus 0.5 is equal to 1 plus 0.5 over 2 minus, this is now 0.5 cube over 8. Then you have 0.5 to the 4 over 16. That's what you get. Easy. So what you get is now the square root of 1.5 is equal to all of this. That works out now to be 0.5 divided by 2 plus 1. Let's see now. So we have 1 plus, I'm just simplifying this side. But let me just write it so you can actually go along with what I'm saying. 0.5 over 2 is 0.25 minus 0.5 cube divided by 8. That is a very small number. I'm getting 0.0156, somewhere of that sort, plus 0.5 over 6, 0.5 to the 4 over 16. I am getting plus 3.9 times 10 to the negative 3. So I need to add up all of these now. So what I'm getting now is a square root of 1.5. According to my formula, it's equal to, adding up those, 1 plus 0.25 minus 0.0156. Then I have plus 3.9 times 10 raised to the minus 3. So what I get is 1.23. This is what I'm getting, 1.2383. That's my answer. Nice. That's the 4 decimal place. You have to follow what the question said. It said to 4 decimal places. This is key. 1.2383 I get. Now let's verify if my solution is accurate. So let's go around here. We want the square root of 1.5. And that's 1.224. So we are relatively close, but not 100%, which is the same. Now, one thing I want you to realize is that notice that this one gives us 1.23. That's the square root of 1.5. This question up here also asks us for the square root of 1.5, because the square root of 3 over 2 is 1.5. And notice that this one was more accurate, and it only went up to x squared. But why it was so accurate? Because it combined 2 expansions. And this one right here was a little less accurate, all right, but reasonable enough to work with. All right. Now let's look at this one now. It says find an expansion for x minus 1 over x squared plus 5x plus 6. Now this looks tough, don't it? Find an expansion up to x cubed. Yes, man. So let's go ahead and tackle that one. Before we can even tackle that one, so to find an expansion for x minus 1 over x squared plus 5x plus 6. First thing we have to notice is that we have to break this up into partial fraction. So we have to break this up and say, well, we know that this is going to be x minus 1 over, this look like x plus 2 times x plus 3, definitely. That is x plus 2 times x plus 3. So since this is what we definitely have, x plus 2 times x plus 3, now we need to break this up now as a over x plus 2 plus b over x plus 3. Yes, we have to do partial fraction first. And then now we can actually simplify this. So we need to solve for a and b. So let's go ahead. We know that the LCM is definitely going to be x plus 2 times x plus 3. That's definitely what we're going to have. And so now what we're going to do is we're going to say x plus 2 into this denominator, leave x plus 3. So this works out to be a times x plus 3. That works out to be a times x plus 3 plus b times x plus 2. That's what we're going to have, b times x plus 2. And so what is this working out to be? So of course, we're going to equate numerators. Of course, equate numerators. So we're equating numerators. That's the next step. Equating the numerators, what we're going to be getting is x minus 1 is equal to ax plus 3a plus bx plus 2b when we equate our numerators. Now after equating our numerators, we then equate the x terms to see that x is equal to ax plus bx. So dividing through by x, that is going to give us 1 is equal to a plus b. That's equating our x terms. And equating our constants, we're going to see minus 1 is equal to 3a plus 2b. So what I like to do is from these two equations, from this and this, I'm going to multiply this one by 2 to get 2 is equal to 2a plus 2b. You might say, why did I multiply by 2? I like to multiply by 2 to the elimination method. Then I have minus 1 is equal to 3a plus 2b. And then I like to eliminate, so I'm going to subtract them. So what I'm going to get is 2 minus minus 1 is 3. 2a minus 3a is minus a. 2b cancel. And so a equals negative 3. So that implies a equal negative 3. If a equal negative 3, if I were to have negative 3 right here, negative 3, and I bring it over, I'm getting b equal 4. Is that 4? B equal 4. Just to play it safe, I'm going to check it in here. 3 times negative 3 plus 2 times 4. Yep, so B equal 4. So that means that we can rewrite this now as this fraction up here can be rewritten as 4 over x plus 3. This is now 4 over x plus 3. Then minus 3 over x plus 2. Minus 3 over x plus 2. Nice. So now we can actually find the binomial expansion because we have to now rewrite this as x minus 1 over x squared plus 5x plus 6. You have to now tell them that we just found out that this is 4 over something. We found out that this is 4 over x plus 3. So we're telling them that we found that this is 4 over x plus 3 minus 4 over x plus 3 minus 3 over x plus 2 minus 3 over x plus 2. Since this is what we found now, of course, we can rearrange this as well as 4 times in bracket x plus 3 to the negative 1. 4 times x plus 3 to the negative 1 plus, well, actually minus This is now minus 3 times x plus 2 to the negative 1. That's how we rewrite this right there. Now, of course, we can also go further and say that we know that we have to write it in the form 1 plus nx. We have to write it in the form 1 plus nx. So we're going to have to factor out 3 from in here to rewrite this as 4 times in bracket. I'm going to factor out 3. So this is now 3 times 1 plus x over 3. This is 1 plus x over 3 raised to the negative 1. I factored out 3. Then I'm going to have minus 3 times. Then in here, I'm going to factor out 2. So I'm going to factor out 2 from in here. So in here, going to become now 1 plus x over 2 to the negative 1. I should have been putting a negative 1 on this outside because it's everything to the negative 1. So look, if you don't believe it, if you were to expand in back the 3 times 1, give you 3. 3 times x over 3, that will give you back your x. And so then everything would be fine. So all of this is just going to simplify down to be 3 to the minus 1 is 1 over 3. So this is going to work out to be 4 times in here. In here actually now becomes 1 over 3 times 1 plus x to the negative 1. One plus x over 3 to the negative 1. Yes, man, this is a lot of work. That's what that side becomes. Then this side is going to now simplify to be minus 3 times the 2 to the negative 1 is a half. So you get a half into 1 plus x over 2. 1 plus x over 2. And that x over 2 is now raised to the minus 1. So now you can just go ahead and simplify to rewrite all of this now as 4 over 3 times 1 plus x over 3 to the minus 1 minus 3 over 2 times 1 plus x over 2 to the minus 1. Yeah, man, that's what you do. Now you can go ahead now and to use binomial expansion for this. All right. So finally, we're writing this down one more time. You're probably saying, oh gosh, how much time we're writing down this thing? We'll finish now. So we can finally tell him that x minus 1 over x squared plus 5x plus 6. We can tell them definitely that this is now, let's change the color. Can definitely tell them that this is 4 over 3 times x plus, no, what was this? This was 1 plus x over 3 to the minus 1. 1 plus x over 3 to the minus 1 minus, this was now, I think it was, what was that? Let's look back. 3 over 2. This was minus 3 over 2 times 1 plus x over 2 to the minus 1. So if this is what we have now, we just have to remember that these things, we can easily break them down now. We can break them down quite easily. We can break this down now. I say this is equal to, this is now 4 over 3 times. We can break up this part right here using binomial theorem. This part now is 1 plus nx. So it's 1 plus n times x. N is minus 1 times x, which is x over 3. 1 plus nx plus n, which is minus 1, n times n minus 1, which is minus 2, over x squared, which is going to be x over 3 squared. And this is divided by 2 factorial, divided by 2 factorial, or 2, plus, this is then now plus n, which is minus 1, times n minus 1, which is minus 2, times n minus 2, which is minus 3, over times x over 3, and this is all cubed, over 3 factorial. I know this one is a lot of work. It is over 3 factorial, which is 6. That part is 6. Close up that bracket. Minus, this is now minus 3 over 2 times. So minus 3 over 2 times, in here now, minus 3 over 2 times this part. Let's do that part in a different color. We're doing this part now. That is going to be 1 plus nx, which is minus 1, times x, where x is x over 2, plus, this is now n, where n is minus 1, times n minus 1, which is minus 2, times x squared, which is going to be x over 2 all square, over 2 factorial, which is 2, plus, then it's going to be n times n minus 1 times n minus 2, that's minus 3, over x times, I should say, x over 2 all cubed, and this is of course divided by 6. That's divided by 6. All we need to do now is simplify this. So let's go ahead and simplify this. Now simplifying this, let's do it on a fresh page. So simplifying that will be equal to, simplifying it, we're going to have 4 over 3. It's going to be 4 over 3. And this is now being multiplied by, simplifying it, this is now 1 plus, this is minus x over 3. That's going to be 1 minus x over 3. Yeah. 1 minus x over 3. And this is going to be 2. And this is x squared over 9. So that is now, this is 2x squared over 9 divided by 2. So that is now 2x squared over 18. That part simplifies to be 2x squared over 18. Let's just check that one more time. Minus this times this, that is 2. 2 over 2 cancel. This 2 over 2 will cancel. This is x squared over 9. Yeah, it's right. This is x squared over 9. So let's just simplify it in one step. This is x squared over 9. Is it plus? Let's check again. Minus and minus, yes, plus. Now this one, minus, minus, and minus is minus. But the 6 right here cancel the 6 here. So we get x cubed over 3. X cubed over 3 is x cubed over 27. So that's minus x cubed over 27. Then we'll close that bracket. So now what we have is now minus 3 over 2 times, we're simplifying what's in the other bracket. It is going to be, this is now 1 minus x over 2. 1 minus x over 2. 1 minus x over 2. And this is now minus, the minus 2 right here, or the minus and minus make it plus. This 2 cancel this 2. So left back with x squared over 4. This is now plus x squared over 4. And then finally, what we have right here is minus become minus. This is minus 6 over 6. 6 cancel the 6. So we have minus x over 2 all cube is x cube over 2 cube, and 2 cube is 8. We're done. All you need to do is just write them as one thing. Writing it as one thing, first you want to do is expanding the tree. So you just get 4 over 3. I'm grouping my constant then first, 4 over 3, then my minus 3 over 2. If I were to group my constants together, all right, let me do it in order so it makes sense. Let's be very organized. This is 4 over 3 minus 4x over 9. Then this is now plus 4x squared over 12. 4x squared over 12. And this would be minus 4x cubed over 3 times 27 is 81. Then over this side, that's going to be minus 3 over 2. And this is going to be minus, plus rather, 3x over 4. Then this part is going to be minus 3x squared minus 3x squared over 8. Then finally, that is going to be plus 3x cubed over 16. This is what we get, 3x cubed over 16. Now that this is what we get, how good? All I have to do now is simplify. 4 over 3 minus 3 over 2, put that in a calculator. 4 over 3 minus 3 over 2, that's minus 1 over 6. This is minus 1 over 6. Then you group your x term, minus 4 over 9x, and 3 plus 3 over 4. We have minus 4 over 9 plus 3 over 4. You get 11 over 36. So you get plus 11 over 36 x. Then we group our x squared term, which is this and this. So you have 4 over 12 minus 3 over 8. And you get minus 1 over 24 x squared. So you get minus 1 over 24 x squared. Then finally you group your x cubed terms, and what you get is this and this. So that is 3 over 16 minus 4 over 81. You put those in a calculator, you get a crazy number. You get 179. You get plus 179 over 1,296 x cubed. And that is it. That is your answer. Soft. Capital T. Soft. This is your answer. Soft. Nice. So let's go ahead and do that. Let's just write it down. We saw that when we expand it, just to write it roughly on the sheet, we can tell them now that we found that x minus 1 over x squared plus 5x plus 6. We can finally tell them that we know that this, we saw that this was working out to be minus 1 over 6. That was the constant. I can't remember these numbers so clear. So let's look back at it. It was 11x over 36. So plus 11x over 36. Then we had our x squared term, which our x squared term was minus 1 over 24x squared. So that's going to be minus x squared over 24. And then we found that our x cubed term, this was plus 179 x cubed, 179 x cubed. over 1296. Easy, soft, capital T, easy, soft, nice. That is that. All right, that takes care of binomial expansion.